Hey guys, what's up? This is Madan sir here, and I've come up with the next video this time. And this time it's from the next topic from the electrochemistry. Probably some of you know, and but probably you may not know. But the topic, the last time I did was it was about the conductance and its relation with the dilution and how actually dilution affect conductance, conductivity, and molar conductivity. That was the topic I did last time, and I hope you are watching and you are really going to get that information you were looking for. And I hope this video, which is going to be the next part of the conductivity as well, so going to be as good as for you the other videos from the same chapter has been. So let's start with that. And the topic I'm about to let you go is called limiting reagent. So limiting molar conductivity. I'm sorry, limiting molar conductivity. You know what? This is really an easy one and also very important one. If you remember, I told you that on dilution, what happened? Conductance increases, conductivity decreases, molar conductivity also increases. But let me tell you exactly what limiting molar conductivity is first. When you dilute a solution up to an infinite level, right? What that means? Infinite dilution means you put so much of solvent that the solute amount goes absolutely negligible. So when you do that, you can say it is, infinite dilution, right? So let me write so that you also copy that and understand on your own also. So when an electrolytic solution is diluted infinitely, the concentration of electrolyte approach nearly zero. At that time, the conductivity of solution, conductivity of that solution is called limiting molar conductivity. Limiting molar conductivity. Right? So I hope you have understand what I was trying to say is like, when you increase the concentration of water in a solution up to a very, very high level, what happens? The solute concentration goes small, and the time comes when it becomes absolutely negligible. So at that moment of time, you can say the solution has become infinitely diluted. So at that moment of time, the conductivity of the solution is called limiting molar conductivity. And this one is represented by lambda naught. So this is the symbol of the limiting molar conductivity, and this is equal to limiting molar conductivity of cation plus limiting molar conductivity of anions. Now, what next I have to tell you, let me repeat back this particular statement here. It simply says that conductivity of an electrolytic solution on infinite dilution is called limiting molar conductivity, but this is calculated something like this, and then there is a rule coming up, very, very important, and this is called Kohlrausch law. So this is going to be your next topic. law. Just make it on your own. I'm not sure about the spelling right there. Kohlrausch law. It states that that when a solution contain a number of electrolyte then limiting molar conductivity of the solution is equal to contribution equal to sum of contribution of individual ions. So what that means? Kohlrausch law says that if a solution contain one electrolyte or more than one electrolyte, then the limiting molar conductivity of that particular solution is equal to the limiting molar conductivity of all the ions present inside. So I've made in my word in different way. So what that mean here? The same equation I'm going to repeat back here. So limiting molar conductivity is equal to sometime what happened, this limiting molar conductivity is also represented by gamma. This is also represented by gamma here. So limiting molar conductivity of cation plus limiting molar conductivity of anions of all types. So this is what the Kohlrausch law is. Let me take you through the importance of the topic here. So I'm talking importance of the third is importance of Kohlrausch law. There are mainly two basics importance here. First, we can find out individual limiting molar conductivity of cation or anions. What next we can do? We can also find out, the limit, find out the degree of dissociation of an electrolyte is calculated. With the help of this law. Now the question is how? If you remember, alpha, which is also called degree of dissociation, this is calculated as lambda upon lambda naught. What third application is, we can also find out the dissociation constant. for an electrolyte solution. Electrolyte solution. How? Remember, there was a formula Ka is equal to C alpha square upon 1 minus alpha. Now what I'm going to do, I'm placing the value of alpha here. So this is going to be C and C multiplied by, molar conductivity divided by limiting molar conductivity square divided by 1 minus limiting molar conductivity upon molar conductivity upon limiting molar conductivity. Now if you solve it, you can take it through your own level, but what you can do, you just have to solve it. So this is what the formula is. This is what the formula is for degree of dissociation. So if you know the Kohlrausch law, these are some of the importance coming out to be from that law. Now what I will be doing, I'm going to explain them all together and then I will take an example. So let me repeat back the whole thing. In case you have you have to copy, just make sure you do that. Okay. So I said on infinite dilution, the conductivity of an electrolyte solution is called limiting molar conductivity. And what infinite dilution means? That the concentration of electrolyte approaches almost zero. And then there is a law, Kohlrausch law I came to. Kohlrausch law says that when a solution contains a number of electrolytes, then the total limiting molar conductivity of the solution is equal to the sum of the, all the cations and anions limiting molar conductivity that is producing or that is being reacting during the reaction. So there is the sorry, I've already wiped that off. So I hope you have copied that. Now the third thing I mentioned you, what is the importance of the Kohlrausch law? With Kohlrausch law we can find out the limiting molar conductivity of individual ions. Second, we can find out degree of dissociation, which is alpha here. Alpha, what is the value? What is the formula for alpha? Alpha is equal to molar conductivity upon limiting molar conductivity. And then we can find out degree of dissociation. Using degree of dissociation, we can find out dissociation constant. Right? What K is called here? It's called dissociation constant. I hope you know that, but somehow I'm writing. Dissociation constant. Right? And what this alpha is? This is your degree of dissociation. Degree of dissociation. So this is about limiting molar conductivity, Kohlrausch law and its application. Now what I'm going to do right now, I'm taking an example based on this. An electrolyte solution contain NaCl and HCl and sodium acetate. Now their AC is represented as acetate, and their limiting molar conductivity conductivities are 6 here, 126.4, and for HCl it is 425.9, and for sodium acetate it is 91 and 91. And of course you do know what are the unit of Siemens centimeter square per mole. Now there's something I remember here, I didn't tell you earlier, that the limiting molar conductivity has also a unit of Simon centimeter square per mole. Why? Because this is also molar conductivity. The only thing that is different, it talks about the infinite dilution when the concentration approaches to zero. So its unit is also the similar as you have studied in the previous video I made. I must say, in case you haven't studied my previous video, you haven't watched it, go and watch it, because everything basics about electrolytic conductance is there. So you have to watch it. So an electrolyte solution contains these three salts, NaCl, HCl and sodium acetate, and their individual limiting molar conductivity is here given. Now we need to find out, calculate limiting molar conductivity of hydrogen acetate. So this is what the question is. So there are three ions here, three electrolyte here, 1, 2 and another one is here, 3. Their conductivity has been given and you have to use them to find out the molar conductivity of this one. So according to Kohlrausch law, what we will do? We will do some of these, 3 electrolytes. How? You do know that NaCl in aqueous medium produces sodium ion and chloride ion. And its conductivity you have is 126.4. I hope you're understanding. I'm talking about limiting molar conductivity, not conductivity, but I'm taking in shortcut. So 126.4 Simon centimeter square per mole. Okay, the second one we have in our list is HCl. So what will happen? HCl produces 2 ions, H plus and Cl minus. And there the conductivity is 425.9 Simon centimeter square per mole. And then what you need to do, just make this equation 1 here, make this one 2, and similarly I'll be making a third equation, and that goes for sodium acetate. So what will happen? This will also produce 2 ions. One will be sodium and other will be acetate ion, and these two have their conductivity of 91 Simon centimeter square per mole. Make this equation 3. So in order to find out the hydrogen acetate limiting molar conductivity, I'm giving a simple trick here. And the trick is that, if you can see, this second equation has hydrogen ion. This one is hydrogen ion and this one has an acetate ion. Right? So what you need to do, add second and third. Just add second and third and subtract the first one. Because once you add them and subtract this one, you will get your hydrogen acetate ion. So adding equation 2 and equation 3 and subtracting equation 1 from. So this is what I'm going to do. So if we do that, what will happen? We will have our hydrogen acetate. So limiting molar conductivity of hydrogen acetate is equal to, as I said earlier, I'll be adding hydrogen acetate, H plus Cl minus, right? Then I have to add this one, sodium ion plus acetate ion, and then I'll be subtracting the first one. So sodium ion subtracted minus chloride ion also subtracted. So what will happen? The sodium ion, they get cancelled out, the chloride ion, they get cancelled out. So what we obtain here? Acetate and hydrogen ion, right? So finally, we are coming to the answer here. So the hydrogen acetate limiting molar conductivity of hydrogen acetate is equal to, I'll be adding second and third, 425.9 plus 91 and minus 126.4. So this is what I have done. Whatever is going to be, that's going to be your answer. Let's make this Simon centimeter square per mole. So this is how the thing has come to an end. In this particular video, I have tried to help you with these 4 basics, steps I just took for all of you. Let me repeat back the whole thing. I started I started with limiting molar conductivity, where I needed to inform you about the infinite dilution. And after I was, done with that infinite dilution, what I did, I explained you about the Kohlrausch law. And after the Kohlrausch law, we came to the importance of that, Kohlrausch law. And finally, we went through the practice using the Kohlrausch law. So with that, I've come to the end of this, video. And I would say thanks for watching, right? And take care.